Something unexpected just surfaced on NASA's Artemis II mission, and hydrogen leaks were only the beginning. During a critical pre-launch dress rehearsal, NASA engineers couldn't just stop a leak. They uncovered a fresh problem that now threatens the launch timeline. Moves to fix it are already underway, but this drama raises a big question. Is Artemis II in technical trouble? And could this shake Artemis III's moon landing plans? In this video, we'll unpack exactly what went wrong, how NASA is responding, and why this moment matters more than you think. NASA's recent wet dress rehearsal for Artemis II was meant to be a routine step, a high-stakes simulation of launch fueling and countdown just weeks before liftoff. Instead, it turned into a vivid reminder that spaceflight is never routine. After loading the SLS rocket with hundreds of thousands of gallons of super-cold liquid hydrogen and oxygen, engineers hit a stubborn problem. Hydrogen continued to leak at unacceptable levels at a critical fuel interface. That alone caused a delay in the mission and pushed launch opportunities into March at the earliest. But here's what's new and catching people off guard. NASA didn't just encounter the lingering fuel leak. They also discovered additional anomalies during the test. According to recent mission updates, a valve associated with the Orion spacecraft's pressurization system required last-minute retorquing, and there were intermittent audio dropouts among ground teams during the rehearsal. These sank the simulated countdown at just 5 minutes before launch, halting progress in a way that exposed deeper system issues. The crucial thing is not just that something broke, but that multiple elements, fuel seals, spacecraft systems, and communication lines, flagged during a single rehearsal. NASA's senior leadership acknowledged this openly and has shifted focus toward comprehensive repairs and data review rather than a simple patch and retry approach. They've already replaced some seals and are analyzing removed hardware to understand why hydrogen leaks reappeared even after previous fixes. This matters because Artemis II is not just another stop in the schedule. It's the first crewed test flight beyond low Earth orbit in decades. Engineers need validated systems with proven stability before letting astronauts climb aboard and push this rocket to the moon's vicinity. A single leak or anomaly could ripple into risk assessments that delay or reshape future missions. By forcing NASA to step back and assess, the rehearsal revealed that the program still has elements that are not yet hardened for flight. So yes, the hydrogen issue is familiar, but what's unfolding now goes beyond a persistent leak to expose vulnerabilities across multiple systems during the most critical milestone before launch. And that brings us to the central question now facing NASA. What does this mean for the mission's timeline and for Artemis III's moon landing ambitions? The stakes around Artemis II have always been high, but the stakes implied by this latest rehearsal are higher than most people realize. NASA executives have publicly stated that they will only proceed when they have full confidence that the rocket and spacecraft are safe and reliable, no matter how long it takes. This means that neither Artemis II nor Artemis III will launch until every anomaly raised in recent tests has been fully examined and resolved. What makes this especially significant is the sequence. Artemis II is the qualification flight for Artemis III's lunar landing objectives. If Artemis II can't be certified because of recurring fuel or system issues, NASA will not risk putting astronauts in harm's way on Artemis III. The launch delay into March is the first visible consequence of this precaution. It's not just shifting calendars, it's reshaping confidence thresholds for a human-rated deep space mission. Add to that the political and programmatic pressure. Lawmakers and space advocates are watching closely. Artemis III is not just another mission, it's a flagship demonstration of American leadership in space exploration. Any delay or anomaly amplifies scrutiny on budget, scheduling, and NASA's long-term strategy towards sustained lunar presence. So while the space agency approaches these issues methodically, the public narrative now includes phrases like new crisis and launch in jeopardy, which fuels skepticism and curiosity in equal measure. This situation underscores something essential. NASA's rocket systems and ground infrastructure are not just mechanical assets. They are interconnected networks of performance, safety, and timing. A single anomaly in one subsystem can cascade into mission-wide risk assessment delays. What NASA is doing now, analyzing seal behavior, replacing suspect filters, reviewing flight termination hardware status, shows they are thinking beyond symptoms to root causes. And that's where the real drama lies. Artemis II isn't just delayed, it's being tested to breakpoints we might not have anticipated until now. The outcome of these analyses will shape not only the next launch window, but also design confidence for Artemis III's even greater challenges. Every decision made in these next weeks echoes in NASA's long-term lunar exploration roadmap. One of the most intriguing aspects of this unfolding story is how NASA is solving the problem, not just stating it. After the wet dress rehearsal ended early, engineers replaced the suspect seals in the hydrogen interface, the very place where leaks repeatedly showed up, and then conducted a partial fueling test to evaluate whether the fixes held up. Initial indications show reduced leak rates compared to the rehearsal, but the agency stressed that data is still under review and further adjustments may be required before another full dress rehearsal is attempted. This approach, iterative testing, data-driven refinement, is exactly how complex aerospace systems are hardened for human missions. The problem isn't simply a leak. It's that hydrogen behaves in ways that are uniquely challenging. Its tiny molecules can slip through microscopic gaps that other fuels wouldn't, and its cryogenic temperatures can warp materials in unexpected ways. NASA is now using the data not just to replace parts, but to understand the physics of the leak behavior itself, so they can design procedures and hardware interactions that are more resilient. What makes this especially compelling is how NASA is balancing immediate fixes with long-term learning. Rather than just tightening seals and hoping it holds, they are analyzing removed components, planning filter replacements, and verifying ground support equipment flows to prevent conditions that might cause leaks in the first place. This isn't patching, it's system-wide evaluation. That effort highlights an important lesson. In engineering, the systems that survive stress tests are not always the ones without problems. They are the ones that expose issues early enough to fix them. NASA's transparency in acknowledging these complications and reworking solutions reflects a culture that prioritizes safety and mission assurance over rushing a timeline. But this also means the narrative about Artemis II is transforming. It's no longer just a hydrogen leak holding up a test. It's now a case study in how NASA identifies, isolates, and remediates complex system interactions under real-world conditions. And every successful fix brings the mission and future missions closer to a higher level of reliability than ever before. NASA's latest Artemis II developments show that high-profile space missions don't just face technical problems. They reveal where understanding still needs to grow. Hydrogen leaks might have been the headline, but the emerging challenge is how the Artemis program adapts its engineering and testing culture to meet the rigors of crewed deep space exploration. This is not failure, it's progress being stress-tested in public. So let me know in the comments, does this feel like routine spaceflight growing pains, or a defining stress test that will shape Artemis for years to come? I'm genuinely curious to hear your perspective. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.